Hello and welcome to this lesson on using machine learning to predict revenue. It is finally time to model our dataset to predict the revenue generated per customer. And the goal of this lesson is to learn how a target variable can be predicted using machine learning. We'll also evaluate our model in this lesson. So as a recap, we've followed the following processes till now. We've optimized the data, we've cleaned it, we've analyzed it, and we've also pre-processed it for machine learning. Now we will conclude this course by performing the following three processes in this lesson: data splitting, machine learning, and model evaluation. But before we start this lesson, please make sure to install the LightGBM library, which contains helper functions to build and train a tree-based machine learning algorithm called Light Gradient Boosting Machine. LightGBM is a free and open source distributed gradient boosting framework for machine learning originally developed by Microsoft, and you can install it using the following command: pip install lightgbm. Since I've already installed it in my system, I won't be running this code right now. So next, let us start by importing the necessary libraries. I'm importing pandas as PD to work with data frames. I'm importing the LightGBM library as LGB to build and train our machine learning model, and I'm importing datetime to work with datetime values. So I'll run all of these lines of code and make the import happen. Great. Now let's import the CSV file called preprocessed_gstore_data.csv, which contains preprocessed information about each user's website visit along with the revenue they generated for Google. So I'm calling the read_csv method over here from the pandas library, and I'm specifying the file path as data/preprocessed_gstore_data.csv, and I'm also setting the low memory parameter as false. So once the CSV file has been read in as a data frame, I'm assigning it to the variable store_df. I'll run this line of code and make the assignment happen. Next, let's look at the first 5 rows of the data frame by calling the head method off of the data frame. So I'll run this, and here we have our preprocessed data frame. Now let's also print the shape of the data frame. So I'm calling the shape property off of the data frame, and we have about 900,000 different rows and 31 different columns. So we started with about 55 columns and we've dropped to 31 columns by the time we've reached to this lesson. First of all, let us split the dataset based on a 70-30 ratio. 70% of the dataset will be used for training our LightGBM model, and 30% of the dataset will be used for evaluating it. For this, we can get the dates before 2017-04-01 as the training dataset, and the dates after that date as the evaluation dataset. So I'm doing that over here. So first, I'm selecting the date column and I'm converting it into a datetime value format. Then I'm extracting the date values from this datetime column. So if the date is less than 2017-01, we're selecting it in the data frame, and this will be our train_df, which is our training dataset. Similarly, if the date is greater or equal to 2017-01, then this will be our evaluation data frame, and we're calling it eval_df. So I'll run both of these lines of code to split the data frame. Please mind that there are other ways to split the data frame, but this is quite convenient for now since we can use it right away. Next, we can check the shape of the training data frame. So if I write train_df.shape, we get the number of rows in it, and this is about 70% of the store_df data frame, and we can also see the same for eval_df. So this is about 30% of the store_df's original number of rows. Next, let us get the target variable y and the features x from the splitted data frames. Please mind that we'll be removing some columns since they cannot be used for training the model. So here I'm getting the target value, which is y, from the splitted data frames. So I'm getting the column totals.transaction revenue as type float, and I'm fetching its values and storing it in the variable train_y. I'm doing the same with the eval_df data frames totals.transaction revenue column, and I'm storing the value as eval_y. Then I'm getting the features from the splitter data frames. So in the train_df data frame, I'm dropping the columns date, full visitor ID, visit start time, and the target variable, since this is not a feature. And I'm setting the access as 1 since we're dropping from the column. So I'm doing the same for eval_df, and I'm assigning them to the variables train_x and eval_x respectively. So if you may be wondering why we are using the latest y and x, this is because in standard mathematical practices, machine learning algorithms have target variable set as small y and the features set as capital X. Okay, I'll run all of these lines of code and let's get our target variable and the features. Now let's create a custom function to train the LightGBM model. So here we have a function called train_LightGBM, and we have 4 parameters going in it. We have the train_x, which is the features of the training data frame. Then we have train_y, which is the target variable of the training dataset. We have the eval_x, which is the features from the evaluation dataset, and we have eval_y, which is the actual target variable from the evaluation dataset. And first, I'm initializing the training dataset by calling the dataset method from the LightGBM library, and I'm passing in our train_x, which is the features, and I'm setting the label as train_y as parameter for this method. Then this training dataset will be assigned to the variable lgtrain. Similarly, we're doing the same for lgeval, where we're passing in our evaluation dataset as eval_x and the label as eval_y, and we're creating a dataset from it. Then we're writing a bunch of hyperparameters for the LightGBM model. And right now, these parameters may seem quite confusing, but let's go over some of them so that we can understand what is happening. So the objective of our LightGBM model will be to perform regression, since we're trying to predict the revenue generated. And the evaluation metric will be root mean squared error, which is a common evaluation metric for regression task. All the other hyperparameters are quite hard to explain right now, but you can go and check out LightGBM's paper and see what they mean. Now let's train the model by calling the train method off of the LightGBM library and pass in the following parameters. So we're passing our hyperparameters, which is params, and it is a dictionary of the parameters. Then we have lgtrain, which is our training dataset. Then the gradient boosting round, which is the epochs as 1000. We have the valid sets, and it is lgeval, which is the evaluation dataset. We are setting the early stopping rounds as 100, and we're setting the verbose, which is the evaluation verbose, as 100. That means we will get a report of the evaluation. Then we're assigning this to our model called model. So once the training is completed, we're returning the model back from the function. Great. Now let's train the model. So I'm calling the train_LightGBM function, and I'm passing in the 4 parameters as we've discussed earlier. Then whatever gets returned back will be stored in the variable model. So let's run all of these lines of code and let's see the training in action. Okay, so as you can see, the RMSE score is quite dropping over here, and the best iteration of our LightGBM model is with the RMSE score 1.77265. And if we had reached a value near to 0, then our LightGBM model would have been 100% accurate, but it is not right now. So we've successfully trained our LightGBM model. And now let us quickly evaluate the model to see how it is doing by making an actual prediction using it. For this, let us select a row of data from our evaluation dataset and the actual revenue for that row of data. So I'll be selecting an index value of 0 to test our model. So from the features, I'm resetting the index of the features, then I'm selecting the index val which is 0 over here by using the iLock property. Then I'm setting this value that gets returned back to the actual x value variable. Then I'm getting the actual y value from the eval_y target variable, and we're selecting the index as 0 again. And we're assigning this value to the variable actual_y_value. So let us run all of these lines of code. Great. Now let's print the feature values and the actual revenue given by actual x value and actual y value. So let's look at the features first. So here for index 0, we have the following feature columns and their values. Similarly, if we print the actual revenue for these feature columns and their values, the revenue is 0. So this customer is not generating any revenue for GStore. Now let us predict if our model can get a prediction close to the actual generated revenue. To make a prediction, we're calling the predict method from the model and we're passing in the actual x value as type float. So I'll run this line of code and we get an array with our prediction, which is 0.003, and this is quite close to 0. So this means that the model is actually predicting quite close with the actual y value. But since our dataset is imbalanced and there are more non-revenue generating users than revenue generating customers, let us select a different index and see how our model performs. So I'll change the index val over here to 8612. The rest is same as before. So we're selecting the features for the index val, which is 8612, and we're selecting the target variable for the 8612 index. So I'll run all of these lines of code again. And now let's look at the new features by running this again. So this is our feature, and let's print the actual revenue this time. So it's 17.84, which is the logarithmic value. Now let us predict if our model can get this correct. So I'm calling the predict method again and we're passing in the feature as type float. So I'll run this and we get the prediction as 10.27 in logarithmic value. So this is quite far off, to be honest, but we can conclude two things from this small evaluation. But before that, as a reminder, you can convert these revenue values to the original value by using the exp_m1 method we had shown in the previous lesson. So we can conclude the following from this small evaluation. The model is actually trained and is able to predict if a customer will generate revenue or not. And the second conclusion is that the model is not able to accurately predict the revenue amount. But this is quite good considering we built this model with 30 plus columns in just about an hour of time. Now it is your time to shine. As an exercise, I would encourage you to take the time to go through all of the steps we've done till now in the course and find different ways to improve the model. Some things that you can do to increase model accuracy are as follows. First, do not drop any of the columns and start with the unoptimized dataset. Then individually go through all of the columns and only drop columns that are not helpful to the model. You can also engineer new features from the dataset based on the available data fields. You can also change the LightGBM model's hyperparameters once you've understood it. You can also use another machine learning model or create an ensemble of machine learning algorithms for getting better results. And you can also use K-fold cross-validation instead of simple data splitting for model evaluation. And you can do even much more, but for that you'll have to research even further.